Hello, so today we are going to solve this Leetcode problem, single element in a sorted array. So the problem says we have a sorted array consisting of only integers where every element appears exactly twice. So we have a sorted array like this, and every element appears exactly twice. Okay, so we have every element appearing twice except one element, like 2 here, which we find just once. And we want to find the single element that appears only once. And the solution here should run in O of log n time and O of 1 space. So if it was O of n time, we could just traverse the array and get the element. What this here says O of log n, so maybe that tells us that binary search could help here. So if we were to binary search, that would be, what would we binary search for, right? The array is also sorted, which even hints more that binary search could be useful. So with binary search, what we are looking for is some sort of a pattern where we have a condition that is false, false, and then becomes true. Can we use this here? Like, one thing we know is that the element, like at some position, right? Let's call it x is equal, should be different, right? So we are looking for an element where, but it's actually not true. The problem here is, even if we find an element where it's not, if x was the index, maybe let's put I here, and this is I minus 1, and it's also different than I plus 1. It doesn't stay true. It's true only for one element. But one thing here is, it's smaller and bigger than the elements next to it, right? The element we are looking for, it's smaller than, let's say, array I is both smaller than the one before it and bigger than the one after it. And the one after it is bigger than it, right? So that's at least a property that we can play with here. There will be a case where, what if the unique element is at the start? But maybe this could be useful. The thing is, this doesn't. This becomes true just once. After that, we have equal. So I think one way we could adjust this a little bit to make it easier is, let's just consider different than the one next to it, right? But how do we guarantee that the element that we find, like, it's this one instead of this one, right? I think what we should do, because the ones in the even positions, those have to have the elements that is identical to the left, to the right of it, right? So always ensure that we can always ensure that mid is even, right? So if we do that, then we could use this function here to decide to go left when this happens, if they are different, because yes, decide to go to the left, because if it's different, either we are in this case, right, or maybe we are in the case where that's the exact number we are looking for, or it's the exact number we are looking for, so high should stay at that mid position, or this is not the case, they are equal, which means we have defined a pair, so we could move our low value to here, right? So I think this should work. So let's start with binary search. We would start with 0, and this would be We could do a low less than high, and we could start out computing mid. And then here we would check if basically mid modulo 2 is equal to 1, which means it's odd, so we want to ensure that it's even, so we can just subtract 1. Then we could subtract 1 here. And now we can do our binary search condition here, which is that the number at position mid is different than the number at position mid plus 1. I hope we don't get like an error here because we are at the end of the range, but let's try this first. So we'd have high equal to mid, otherwise we would have low. Here we could do mid plus 2 because we found a pair. Basically mid and mid plus 1 are equal, so we could skip both of them since that's definitely not the element we are looking for. And then at the end we could just return low maybe. Let's try this. Yeah, so yeah, I made a mistake here. This should be nums. Okay, looks like it worked for that example. Let's try with this one. With that one, we didn't work. We don't even have 4. So yeah, because I'm returning the index, I should be returning the element. Okay, so that looks good for that example. Let's try some other set of examples. Maybe 2, 3. Try another one here, just these 2. Try another one where it's at the end. Yep, so for the end one, we did get let's make this -1. Yep, so that worked there. Let's try one with just one element, and let's try an empty list. So does empty list, the problem doesn't specify if we should have empty list, so let's just, and yeah, for empty list, it's probably not supported because there is no solution. So let's try to run. Okay, it looks good. Let's submit. Okay, so that's accepted. Yeah. So essentially, it's just binary searching for this element, essentially. I think this problem shows that binary search is not always, it's sometimes applicable to even cases that it doesn't look like it would be. Like here, we are looking for a unique element in the array. But thanks to this criteria and this trick here, we could solve it easily. Yeah, that's it for this problem.